This video discusses the show IP BGP command. So this command is used to display entries held by BGP in its table, and as you can see here, the command is show IP BGP, and some optional parameters include specifying the network prefix you're interested in, specifying the mask if necessary, and you can also give an option longer dash prefixes. Now this option, when given, results in the display of routes matching the specified prefix and mask. In addition, any other more specific routes, so those with longer masks, but still matching this given prefix. So for example, here if I say show IP BGP 192.168.0.0, 255.255.0.0 and longer prefixes, then this will show routes to this network if I have one, as well as other ones like 192.168.10, 20, and so forth. So the following slides will give further examples. So actually a lot of these examples we're just about to look at are centered around this particular topology here. So in this topology we have three different ASs, AS 200, 300, and 400. And in this command here on this slide, show IP BGP, we're actually at router C in AS 400. So notice here that we've got three entries listed, so three reachable paths through BGP. And I'll just point out that network 11/8, which is actually in AS 400, is announced into BGP. And notice how the next hop is quad 0, so that is basically it's in our AS, in other words. And the AS path is simply I, meaning that the origin code is an IGP. So it was announced in this same AS via an IGP. Whereas, look at the next network path to 12. So 12/8 is actually an AS 200. And if I look at the next hop, then the next hop to reach that network is actually out of AS 400 to 200, 200, 200.65. So that IP address there, the next hop. And the AS path there says that we have to transit through AS 300, then AS 200, and it was announced by an IGP there. So here we are, AS 400, we have to transit through AS 300 to AS 200 and to get to that network. So that is precisely what we expect to see. And the last one, network 193.10.20, which is represented here, the third path here. Same next hop, of course, out of our AS, but in this case it only goes to AS 300 and will hit the IGP route. That's precisely what we see. Now just draw your attention to some of the other information that's presented on this command. First being the BGP table version. So this is the internal version number of this table. Remember, this is not the BGP version, but rather the table version. So this number is going to be incremented whenever the table changes. So as we discussed before, rapidly advancing table version numbers means we've got some kind of instability because it's being updated very, very frequently. Next is the local router ID. So BGP has router IDs, same as OSPF, same as EIGRP. They're more prominent in OSPF than EIGRP. In BGP, router IDs are again quite prominent because we do need to know them. Then there are the status codes. So just like when you do a show IP route, there's some reminder on the output of what the various codes mean. On this show IP BGP command, it's similar. So this is the status of the table entry. And these status codes are the characters displayed at the beginning of each line in the table. And it can have the various values, where S, lowercase s, means the table entry is suppressed in favor of a summary route. A star means the entry is valid. In other words, that BGP has checked and the next hop is in fact reachable. That's useful. The greater than sign shows that this is the table entry that's the best entry. Now this is important because this is the one that's going to be used and advertised to neighbors. More about this later. And the lowercase I means that this entry, this path, was actually learned via an IBGP session. So not learned externally, but internally. Then at the very end of the AS path, we have origin codes. And these origin codes, not to be mixed up with the status codes that we saw earlier, this is actually telling us where this path was derived from originally. So an I at the very end, as I already mentioned in the previous, shows that this path originated from an IGP. In other words, it was advertised or announced into BGP using a network command. And E here would show that the entry originated from EGP, which is a very old, outdated protocol. You rarely see that now. A question mark as an origin shows that the path was announced via redistribution into BGP, because question mark basically says we can't tell the origin of this other than it was brought in explicitly. Then of course the columns here are the network, which is the network path we were discussing, and then the next hop. So the next hop is the IP address of the next router that is used or to be targeted when we want to forward this packet out of our AS. An entry of quad 0 then indicates that the router has some non-BGP routes to this network. In other words, we actually are in the same AS as this network. We're not leaving our AS. The next columns are metric, local preference, weight, and path. So metric, we will talk a lot more about these three columns, metric, local, pref, and weight. But this is the inter-AS metric. So this is the multi-exit discriminator called a MED that's used between ASs. The local preference is going to be set with different possible commands, commonly with the set local preference route map command, and the default for local pref is 100, or it may not be used at all. Weight is a Cisco aspect only known to Cisco routers, and this is again going to be discussed in more detail later. Path we've already talked about. This is the AS path, and remember that each integer value here represents an AS number that's along the path that must be transited in order to reach the destination network. Here's a different example. So not the one we showed with the topology before, but just to show you how some of these other codes may come into play here. So here we're on another router called router A, show IP BGP, and you can see here that, for example, multiple paths here, 10.1.0.0/24, there are two paths known. 10.1.1.0.24, only one path known. 10.1.2.0, only one path known. But then 10.97.97.0.24, three paths known, as are three paths known for each of these other ones, and so forth, and some output's been omitted. By the way, the previous show IP BGP did not show a slash whatever because they were the classful mask. So if it's the classful mask, you won't see that, but if it's subnetted like these are, because 10 is native class A, right? Native /8, and so forth, right? So 172 is native /16, it's a class B, it's a subnet as well, and that's why they're shown. So in this example anyway, some other multiple paths and some different codes. So let's have a look at that. So actually let me go back and I'll discuss these codes and then I will go back and you can have another look at them. So a D status code here shows that the route is being dampened. Dampened means that we've been penalized for going up and down too often, and that means that updates for this route won't be accepted for some period of time. So the route might be up right now, but it will not be allowed to be advertised until the penalty has expired. So this is how BGP works. One of the things that BGP does is, in order to impose more stability, if your route is changing too often, then it may be dampened and further updates may be refused for some period of time. It's like being in the penalty box. H means history, so that means that the route is not available. It's probably down, but there's some historical information and we're going to keep it just for some period of time. So there's no best route, it's not being advertised. R means that this routing entry is not being installed into the routing table. So this is what we mean by like a rib failure. And the reason for this route not being installed can be displayed by using this command, show IPBGP rib-failure. A capital S shows the route is stale, and that's only used if you're using a non-stop forwarding in a router, and that's outside the scope of this course, but I just want to mention that for completeness. So if I go back, you can see now that some of these paths, for example, were learned, let's say 10.100/24. The second path was learned via an IBGP connection. So the ones not tagged I are by default an external connection. So this, or basically just announced in, so not an IBGP connection. So this first path, this is the best path. It's not out of our AS, for example, and you can see the AS path is just I. Sorry. Whereas the second one is not the best path, so it hasn't been chosen. We'll talk about best path selection later. These next ones, they're both the best path because, of course, there's only one. In the case of 10.97.97.0/24, there are three possibilities. So notice that one of them is learned internally, and notice that the AS path in both cases, there are actually two ASs to transit through. And I can tell that that the destination exists in AS 64997, right? Because it was announced via an IGP, and then it transited through AS 64998 before coming into this AS. Notice then further down below, every path to 172.31.10/24 has been marked with an R, meaning rib failure. So it's not being installed in our routing table, and we won't know why unless we drill down further. The other thing I show on this slide here is that using this command, the networks are going to be displayed from the lowest numbers up to the highest numbers.